now I'm going to introduce the next speaker, Andras Iklody, coming from MISP, who is going to talk about open source threat intelligence. Welcome, Andras, and thank you for the talk.
Welcome all. First of all, sorry in advance, this talk will be a little bit out of band basically for the rest of the conference, because I'm coming from a very different background than most of the other presenters in here. I'm coming from a national CSIRT background basically. So the tool that I'm going to be talking about is called MISP. We've been building this thing since late 2011, early 2012. And we've been going with CakePHP ever since, so we're pretty long-time believers in the framework, although we've been pretty silent about our involvement with it, because we're kind of keeping to ourselves. A little bit about us, who we are and who I work for. I work for Circles. For those of you in Luxembourg, you might know us. We're basically the national CERT for the private sector in Luxembourg. That means that we're basically funded by the government of economy, the Ministry of Economy, to build cybersecurity for our constituency, which Luxembourg being a bit of a weird country in this sense, we have a lot of organizations incorporated in Luxembourg, so our scope is pretty large with who we build our tools for. Luckily, our ministry is being very generous with giving us an open hand on building just open source tools. So basically that's what we do. Everything we build is open source and free. So, including the tool that I'm going to be talking about here, MISP itself. So if anyone is interested, anyone wants to build a security team and wants to build security tooling, we're here and happy to help it. We generally consider ourselves, because of this, as open source toolsmiths. So I'm going to mention a few other tools that we build, but basically everything we do is openly available for all. So our relationship with MISP is kind of twofold. First of all, we lead the development of the tool, as well as we're big users of the tool itself. So we run multiple communities in the security niche that deals with information exchange from all sorts of organizations. A bit about some metrics about MISP itself and the open source contributions. We have a pretty large community from the security sector contributing to the tool. We're currently, for the core software itself, at around 25,000 commits. We have merged around 3,000 PRs, and we have about 500 contributors or so to the core software itself. That means we still have a bunch of other projects that are connected to it, where people develop their own taxonomies, libraries, and so on. But it's a pretty big community. If you're interested in some more metrics, we publish all our metrics with heat maps on when we all develop tools, how we collaborate, and so on that site that was linked here. So a bit about the tool itself. So what is it for those of you that haven't heard of it, which I think will be quite a few. Basically, MISP is a threat intelligence sharing platform. That means that it is a platform that is meant to share everything that relates to cyber threats with partners. So that means we have large networks of sharing where we exchange this information between different peers. We have built it using CakePHP since day one, and we've stuck to it ever since, and we're going to continue sticking to it. So it has worked really well for us. So both from a security aspect as an ease of development aspect, it's really great to use. So we're super happy with it. It's a tool that is basically deployed at a lot of CSIRTs, SOCs, and basically any cyber threat researchers around the world. So we're currently tracking over 50,000 installations of MISP for various teams, which has different meanings of how many users it has. I'm going to get back to that in a bit. But basically there are a lot of installations and a lot of users of the tool. Everyone can deploy their own, so the idea behind the tool is it's a platform that you can host yourself, or you can connect to someone else's MISP and become a user of someone else's platform. So we're a little bit similar to what Passbolt does in this sense, that we're building more an application rather than a website with CakePHP. Our paradigms of how we build the software is of course different than what some would expect. Basically, the tool is built to synchronize and interconnect with each other, so you can join communities where your MISP nodes will interconnect with other MISP nodes and start exchanging information. So this is one of the largest parts of the tool. Besides just keeping your threat intelligence and managing your threat intelligence, it also allows you to interconnect and exchange that information with others. And there are a bunch of different network topologies you can use for that. So besides the tool itself, we also publish a bunch of open standards around threat intelligence. So for those of you that are coming from that field, you'll probably know us from our taxonomies as well, and from the MISP standard itself, not just the tool. We basically publish a lot of guidance documentation for security teams out there, how to set up a sharing community, how to manage your data, how to create well understood data for the community, as well as building basically an ecosystem of tools and libraries that support all of this. And again, everything we do, guides, documents, the ecosystem part, the software, everything is open source, so feel free to reuse it and abuse it. It's basically built for that. Now, a little bit about the objectives of the tool itself. So to give you an idea of what you're supposed to accomplish with the tool if you deploy it yourself, it's a tool that collects information from various sources, first of all. So it collects data from your own analyst. That means if you have a security incident, you can extract information out of the security incident and input it into MISP. Indicators of compromise, knowledge that you've gained about the threat actor, about the attacker techniques that were used, all of these can be modeled in the tool and shared with the community. Once this data is entered, normalize it into a standardized format that allows you to interact with the data and convert it into a bunch of different other formats. It enriches the data, so that means that if you are connected to services that gets you additional information about indicators of compromise, so for example, malicious IP addresses that you've seen connections go to from your network, it will fetch information if you have those subscriptions to, say, domain tools or whatever other services you're subscribed to VirusTotal, and will get you additional information and enrich the information that you're building or threat information package. It will also correlate the information so that you see commonalities between the different attacks that you've seen in the past or one of your peers has seen in the past, so that if you are in an incident response role, that you know what steps to take in your incident response process next. It also allows you to collaborate and basically exchange this information. So we very often as a CSERT, we basically get called into incidents where we have to work with the organization that is under attack, as well as, for example, law enforcement if they get involved, or the public prosecutor, or other certs that get private SOC teams that get involved. So we collaborate with these on the platform itself and exchange information and resolve the incident together. Now, besides getting this information, exchanging this information in the tool, we can also use a lot of automation with the outcomes of these incident and resolutions and other feeds that we pull in and so on. What we can do is we can take all this information and feed our protective tools. That means if we have IDSs, firewalls, SIEMs, and so on in our network, we can directly hook those into MISP and feed those with the most relevant information coming from our community, coming from feed vendors, coming from security researchers, and so on. And finally, the other thing that we do with it is we present a live image of what is happening in your community. That means if you're part of a MISP community that is specific to, say, Luxembourg, or that is specific to a sector, you're going to be able to see information of what are the threats that my peers are facing, what should I be investing in terms of tooling to remediate this. If you see that there is a massive rise in ransomware, well, maybe that gives you an idea that you should be investing in backup solutions, and so on. So the whole thing started for us in 2012, a bit of a historic look back at what happened. At the time, I was wearing a different hat and I was working for a military organization. And basically, one of the things that was going on was we had a bunch of different organizations that were interfacing with each other, military organizations, national certs, and so on. But at the time, the way we were exchanging information was regular meetings every other month, where we were exchanging information about the ongoing attacks. And one of the things that we noticed was there was a certain campaign going on in 2012, which was affecting several of us at the same time. And we noticed that our reverse engineers were working on figuring out what the malware was doing at the same time for weeks in our own little silos. Now, this was an absolutely massive waste of time, duplication of work that we could have avoided if we had a way to share this immediately. So at the time, a chap called Christophe van der Plas, who was working for the Belgian Ministry of Defense, started building a tool in his free time, testing out how CakePHP works as a hobby project. Picked it up, and this whole thing became MISP afterwards. So it all started really small and grew into this beast over time. Since then, it was a community-driven effort where we had different input from all sorts of sources that gave us ideas how to improve the tool and what they were needing. Initially, this all happened within our own organizations. So going back to the initial use case, it was literally just malware reversers solving their own issue. We were sitting there and basically wondering how can we share this information that direct peers that we normally exchange emails with. And one of the things that was an outcome of this, that we had the security analysts. Usually at the time it was very common that the operations and the security team and the part of the security team dealing with reverse engineering and so on were tightly coupled and sitting usually next to each other. And they were interested in the outcome of this, obviously. I mean, the reversers were extracting indicators of compromise. The security analysts wanted to take those indicators of compromise and plug it into their protective tools. So they were like, okay, that's great. How can we get onto this platform that you have where you're sharing this with each other, and how can we start pulling this information into our protective tools in a faster way? So we started modifying the tool so that they could do that. We had exports to the various different tools. We had a bunch of automation pipelines going on and so on. And the interesting thing is once you put these things together, you get other groups interested. You have the intelligence analysts that are tracking individual threat actors. Those usually, again, were a group that we didn't interface with a lot, or only in irregular times. They were interested in putting timeliness and on these different attacks that the organizations were seeing, as well as tracking the different changes of attacker techniques. So they got interested and they wanted to start having tools that allows you to dig into the data, to extract knowledge out of the data. Same thing happened with the risk analysis teams. They were interested, what can I tell our different constituents? What should they be investing in? What training should they apply for? What risks are they facing recently? Again, this data is a great basis for that. Because once you start pulling in information from different sectors, different regions, you see what, the overlap and the difference between the different threats that these organizations are facing and how they're evolving over time. Over the time, we also opened up to other types of organizations out there. So one of the things we saw first, being situated in Luxembourg, there is no secret that we have quite a few financial organizations hosted here in Luxembourg. They came to us and said that it's great, we're using MISP for the cybersecurity aspect, but we have some other security concerns that we also would like to share our information with our peers with. For example, fraud information, mule account information. So the fraud teams approached us. So we started modifying our data model, and this will go back to a little bit into some of the interesting things for the Cake community out there. One of the things that we try to build is a more modular data model behind the scenes, where we allow to basically model different concepts on the fly. So we're going to touch on that a little bit. And we expanded this to some other groups as well, like law enforcement, military, disinformation research, and so on. So a bunch of different groups jumped on board. And nowadays, if you look at the data model of MISP, it's basically housing a lot of different types of objects that we can share. So all in all, the reason why we do all of this is to make our own lives easier as a CERT. So that means this helps us in our day-to-day work. It became our central tool in our CERT operations, as well as a way to interact basically with other organizations. Now, one of the things that we noticed quickly is that if we started solving issues for other types of organizations out there, whenever they had an incident and needed to get in touch with us, they already had the tooling to do that and the culture of sharing information, so that it was much quicker for us to get involved, to get the evidences that we need to start our work, and to help them resolve their cyber incidents. Now, one of the secondary goals with all of this that we had was that we wanted to basically democratize threat intelligence for all. Not necessarily the data itself, because obviously a lot of threat intelligence comes from vendors that are selling feeds and so on, but the methods and the ways of creating threat intelligence. This was something that was really only in the hands of certain vendors rather than the community at large. And finally, one of the things that we wanted, this is kind of a stretch goal for us, it is still ongoing. We want to build a full tooling chain for cyber operations centers out there. So that means anything from the threat intelligence part to all sorts of tooling that you use for extraction. So a little bit, I'm not going to go through all of this because this is a massive wall of text. So just to give you an idea what sort of organizations out there are using the platform and who's exchanging this information. So we're operating basically a large community for the private sector, obviously, since that's our mandate. We have about nowadays closer to 3,000 organizations that are involved in our platform. It goes from anything really small, like SMEs, all the way to large organizations and internet providers. So we have all sorts of massive ones as well, exchanging information and everything in between. As well as a lot of other groups that we're not directly involved in as well. So basically, we have these two hats. One, we run some communities for Circle. On the other hand, we provide the open source tool. So that means with the open source tool, there are a bunch of organizations that are spinning up their own communities. The only reason we know about them usually is because they ask us to help them with some bugs or configuration issues and so on. So there are a bunch of trust groups out there, be it national, sectorial, and so on groups. Financial sector groups like banks and ISACs that are running their own sharing communities. We have a bunch of different military organizations out there. One of the biggest users of MISP is NATO. So MISP is deployed across a bunch of different NATO organizations, and that's how they exchange information about cyber threats with each other, as well as national CSIRTs, governmental CSIRTs, and so on around the world. Besides that, a bunch of security vendors are basically selling their feeds through MISP. So they're using MISP as a vehicle to deliver the data to their constituents, so that it's immediately actionable data on their side. Normally when you're sharing feeds, you still need some tool to ingest it. MISP will do that for you, and it will convert it to a bunch of different formats so that you can feed your various different tools from different vendors. There are also a bunch of different sectorial communities, so if any one of you works for a telco community, an ISP or something, you're probably part of a MISP sharing community already, where you're exchanging this information. Also, there are some topical communities. These can be sometimes funky and pop up overnight. For example, COVID-19 and our fears of the tracking of the virus made us spun up a MISP instance where we were tracking basically travel information, articles, and so on as it was coming around. But it can be used ad hoc for a bunch of different things. There are also disinformation MISP instances where folks are tracking election interference campaigns or disinformation about medical information, and so on and so forth. So to quickly explain the pipeline of how it works, MISP ingests data from different sources via the UI. Analysts works, sensor data, data coming from other communities with this MISP to MISP exchanges, from various feeds from vendors, as well as internal tools. We have a bunch of different tools that collect data. For example, we have a public address where folks can forward spam to us that we can analyze for them, so that data goes into a MISP, for example. So these are the type of tools that can collect data for you and generate MISP data for you. Now, after all of these ingestions, we pipe the data through filters. We filter out what is junk and we modify and harmonize the data. We push it through a processing engine that will enrich the data, that will allow us to collaborate with the data with others, that allows us to correlate the data, so see similarities between different attacks, and push it through various custom workflows where users can define, okay, when I get this data, I want, for example, in certain cases, having a message in our company Slack or something like that. That would be such a workflow that you define, or workflow could be pushing it to various different internal tools for detection and so on. So you can define those in the tool itself. Finally, the dissemination system allows us to really push the data to all sorts of different endpoints, be it other MISP instances, so other organizations perhaps, or perhaps internal MISP instances that we have. It allows us to also push the data to various tools like dashboards, our protective tools, analyst tools, and so on. And we have a bunch of APIs that allow you to basically fetch this data whenever you feel like it. So we either push the data through message queues, or we allow users and tools to ingest the data via APIs. Each of these have various different filtering tools applied to it that allows you to filter out things like false positives. If anyone has ever worked in a SOC, the most annoying thing is the constant alerts for things that are junk. So someone tripping over something that is obviously Facebook.com and someone encoded as an indicator, that's annoying. We want to prevent that. So how is this relevant to the CakePHP community? I mean, first of all, everyone has some security concerns in their organization. Nowadays it's difficult to avoid that. If you do, it might be a tool that might be handy for you, for your security team, to spin up, open source, give it a shot, try ingesting data, and try feeding it to your protective tools. It can go as small scale as me running this at home to feed my Raspberry Pi's DNS-based block list, so that nobody in my family goes out to annoying sites that shouldn't be visiting, all the way to really large operations and running large security operations through it. Basically, anytime you deal with automation, it makes your life easier. If you're also dealing with security incidents in a collaborative way, it is great because you can really start real-time exchanges of the information with other partners. Now, this is from a security perspective. Now, from a development perspective, why would you be interested, for example, in the code base, in the libraries, and so on that we produce? We've been building this beast for a long time, and we had some unique issues to solve because of the type of organization we are and the type of tool that we're building that might not be relevant to most, but some parts might be relevant, and we might have solved some issues that might be relevant for you. So the idea is to go through some of these and some of the solutions we have. If anyone is interested in those libraries and those solutions, we'll talk about it a bit. Before we get out of the way, our tech stack. So MISP currently is still on Cake 2.x, which is a pain. So we're currently porting it to 4. We're doing this by already having another tool that we built, which is a contact management and orchestration tool called Cerebrat, that we also developed, that is already written on CakePHP 4. And we basically share a lot of the code base. So we built a lot of middleware, and we're basically porting the tool through that middleware over to the other framework. So it's a long process. If anyone wants to get involved in that or has good pointers for us, we're interested. It's been going on for a while, and it will go on for a while. Basically, our backend is a mix of MySQL and Redis. So everything that deals with a large amount of real-time search information, we generally use Redis for. So, for example, cache libraries and so on that we pull in when we are doing overlap analysis with the data of other organizations. On the other end, for persistent data, we use MySQL. Our front end is custom, but we use a bunch of different visualization libraries out there, as well as helper libraries. And again, not the most interesting part in itself. For the intercommunication, we have our custom API for information exchange, but we also use ZeroMQ and Kafka for exchanges to other local tools. So that's not the sync mechanism that we have, that's more the pushing to different tools mechanism that we have built in. We also have a secondary system that is running on a Python framework called Tornado. We use this for a modular system where we can plug in additional modules that plug into MISP. Mostly because in the security community there seem to be a lot that fetishize Python. So this is to make them happy so that they can build their stuff in Python and not touch the core. Also, it gives the core maintainers a bit of safe of mind that no one is touching that part of the code, so it's a bit handy for us too. The background processing currently is done by Supervisor. Previously we were using CakeResc, so it is still there as an option in MISP. So for those of you that use CakeResc, it's super outdated, but it served us really well. So it hasn't been touched the library for a long time, but we've been using it for a long time. Nowadays we move to Supervisor as an alternative. We built a bunch of libraries that are reusable for the tool that we use across Cerebrat and MISP as well. For example, the entire ACL is incredibly granular for different user roles as well as different data distribution settings. So these basically can be ported to other tools. It's a separate library. Our CRUD generation, our correlation engine and so on, these are all separate libraries that can be reused. So if anyone's interested in having a look at those and using it, please feel free. We also have a pretty extensible and customizable data model, so that means that we use JSON-based compositioning for new data models that we then use to describe different concepts that didn't exist in the tool before. So we have one huge part that basically defines the building blocks that is fixed in database, and then we have the compositioning engine that is coming from user-defined models. Finally, we have a bunch of different visualization tools, dashboarding and so on that might be interesting to some. Something that is more annoying and probably more of a security-focused issue. We have to deal sometimes with information exchanges in adversarial conditions. What this means is that in a large network, you might have organizations that suddenly have a very different political or other type of affiliation, and suddenly you have multiple organizations in a network that actively try to attack each other. So in those cases, we need to ensure that the data is validated, that it's tamper-proof. So we have cryptographic signing solutions basically that allow us to propagate changes to data without it being interfered by other parties, even in the mesh network where we only control our own node. So it's a huge topic that is probably an edge case for most. But if you're interested in that, we have quite a bit of write-ups and code on that part. Also, everything we do is basically UI and API, is in UI and API parity. That means everything you can do via the UI, you can also do via the API. We have an extensive workflow management system that allows you to build workflows for the tool, how it calls certain functionalities, how it parameterizes certain functionalities so that you can customize how your own data pipelines go through MISP. So that means you can modify when certain actions get triggered, when certain data gets modified, when we call other tools, external tools to trigger certain actions and so on. Something else that is, oops, the screen doesn't seem to be updated. Oh, there we go. Something else that is very specific to cyber threat intelligence is the scoring of data. So we have quite a few research papers on this topic if anyone is interested in this. It basically deals with creating and custom models for scoring indicators. So that means, who did I get this information from? How much do I trust its source? How long has this information been stale for? What type of information is this? How ephemeral is that information? An attacker can, for example, easily change IP addresses or domain names, but it's harder to change hashes of imports, for example, in your various malware when you're dealing with upstream developed packages. A quick note about another tool that I've mentioned with Cerebrat. Again, if you're interested in our CakePHP 4 implementation already of what we foresee for MISP, this is the tool to look at. There's a large overlap in the code base between the two. We want to have all the same ideas and concepts reflected in both tools. So we're building that already with Cake 4 as our chosen framework, and we'll be moving to Cake 5 the moment it becomes available. Now, finally, before finishing this off, there is a small thing I wanted to still show, which is another tool that we didn't develop, but it came as an outcome of MISP itself. This is coming from a security organization that is doing penetration tests on MISP. So basically the Luxembourgish army has hired a third-party organization to run pen tests against MISP and Cerebrat. Because it is used in a military setting, it constantly gets tested for security issues. And this company, Cybersecurity, has developed a framework for testing CakePHP applications for vulnerabilities. Now, obviously, as with any fuzzer and tool like that, we were a little bit skeptical at first until we got the results from them. So that was really impressive. They statically modified the code base to inject hooks in a bunch of different parts of the code based on certain functions that they're seeing where they could be seeing something that could go wrong. And then afterwards replacing everything back and restoring your code base afterwards. But obviously we do it on a separate test machine. But the interesting thing was they found a lot of vulnerabilities that we never would have detected otherwise. So here are some examples of some of the CVEs that were found in MISP. So this is a tool that gets about 10 to 15 different pen tests a year from different organizations, and nowadays there are very few findings usually. And then Cybersecurity comes and says, okay guys, we found some actual RCE in the tool and SQL injections all across the place. And we're like, okay, that's how did that happen? They built their own tool. It's reusable by anyone in the community. It supports Cake 2 and Cake 4. So feel free to use it. There are some links later on in the slide on where you can get it. It's an interactive thing, so you can build your own test cases and so on. They also offer a free scan if you're interested in that of your tool, if you don't want to mess with the open source tool and set it up yourself. So just reach out to them and get in touch. I really recommend it to everyone. For us, it was quite enlightening of how much they found, basically, and how much we could improve the tool. It allows us to sleep better at night, so that helps. So finally, for us, if you want to get in touch with us, Circle, here are a bunch of different addresses, Twitter, whatever. If you want to get involved in development, please reach out to us. You also have some links for grabbing the tools and so that you can get started on your own. And that's basically it. So thanks for the time. Thank you.